In this problem, we are going to prove that 1 minus sine theta all over 1 minus sine theta minus 1 minus sine theta all over 1 plus sine theta is equal to 4 sine theta second squared theta. Let us copy first the left-hand side of our equation. 1 plus sine theta all over 1 minus sine theta minus 1 minus sine theta all over 1 plus sine theta. Okay, by combining the two terms that we have, we will first find the LCD. In this case, we are going to multiply both the denominator of our two terms. So we will have 1 minus sine theta times 1 plus sine theta. And then, if we are going to divide this LCD by this denominator, we are going to cancel 1 minus sine theta, and then the remaining term, which is 1 plus sine theta, will be multiplied to our numerator. So since both of them have the same terms, we'll just have 1 plus sine theta, and then we square this whole term. Okay? Copy the minus sign, and then we are going to divide this LCD by our denominator, which is 1 plus sine theta, and canceling out 1 plus sine theta to our LCD, we are left with 1 minus sine theta, and multiply it to the numerator, which is 1 minus sine theta as well. We will now have 1 minus sine theta quantity squared. Next, let us expand and simplify. Multiplying 1 minus sine theta times quantity 1 plus sine theta, we will first have 1 times 1. We will have 1. Next, 1 times positive sine theta, we will have positive sine theta. Next, negative sine theta times 1, we will have negative sine theta, and negative sine theta times positive sine theta, we will have negative sine squared theta. Next, if you're going to expand 1 plus sine theta, we will have 1 squared plus twice the product of our two terms, which is 1 times sine theta, and let us square the last term, which is sine theta. Okay, the other term would be, squaring this, we will have 1 squared, and then twice the product of our two terms will be plus 2 times 1 times negative sine theta, and then let us square the last term, which is negative sine theta. So plus negative sine theta squared. Oh, I forgot the squared sign here. Okay. And then let us simplify. Okay. 1 squared is 1. 2 times 1 times sine theta, we will have 2 sine theta. And then if we square sine theta, we will have sine squared theta. Next, 1 squared is positive 1. So we will have 1 plus 2 times 1 times negative sine theta. We will have negative 2 sine theta. And if we are going to square negative sine theta, we will have positive sine squared theta. Okay, In the denominator, we're going to simplify this. So 1, let us copy that 1. And then sine theta minus sine theta will be cancelled since they have the same terms but different sign. And then let us copy negative sine squared theta. Okay, what's next? Okay, let us distribute the negative sign here to all the terms inside the parentheses. We will now have 1 plus 2 sine theta plus sine squared theta. Negative times positive, negative 1. Negative times negative, positive 2 sine theta. Negative times positive, negative sine squared theta, all over 1 minus sine squared theta. Okay, next. We can cancel 1 and negative 1. What else? Sine squared and negative sine squared. Thus, we are left with 4 sine theta all over 1 minus sine squared theta. And we all know that by Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. If we are going to transpose sine squared theta to the other side, we will have cosine squared theta is equal to 1 minus sine squared theta, which is exactly our denominator. So we can replace 1 minus sine squared theta by cosine squared theta. We will now have 4 sine theta over cosine squared theta. And we all know by reciprocal identity that 1 over cosine squared theta can be expressed as secant squared theta. So replacing 1 over cosine squared theta by secant squared theta, we will now have 4 sine theta secant squared theta. End of proof.